Hello everyone, welcome to In 5 Minutes. In this video we are going to design a normalized linear phase FI filter where there is nothing mentioned about the windowing method. So we have to look at the specifications and decide accordingly. So let us have a look on the question. The question is, design a normalized linear phase FIR filter having a phase delay of tau is equal to 4 and at least 40 decibel attenuation in sideband. Now the first thing we notice that attenuation is given. It is 40 decibels. Now we should see that given attenuation is 40 decibel in sideband, and from the table that we discussed in the video we will see that it is closest to 44 decibels. So we should select Hanning window. Here it is also mentioned that it is a normalized linear phase filter. Normalized meaning that its cutoff frequency is 1 radian per second. So omega c is given as 1 radian per second. Now the given phase delay tau is equal to 4. Now phase delay is itself alpha. Alpha is equal to n minus 1 divided by 2. Now here alpha is itself given, that is 4. So 4 is equal to n minus 1 divided by 2. So n is equal to 9. Now we have already selected the window method, so we will go for the calculation of frequency response. Now hd of omega is equal to e raised to minus j omega n minus 1 by 2. N minus 1 by 2 is alpha. So it will be e raised to minus j 4 omega. Now according to the definition of inverse Fourier transform, hd of n is given as 1 by 2 pi integration minus omega c to omega c hd of omega e raised to plus j omega n d omega. That will give us 1 by 2 pi integration minus 1 to 1 e raised to minus j 4 omega into e raised to j omega n d omega. So we'll take this term common. We get integration minus 1 to 1 e raised to j omega n minus 4 d omega. So after integration, hd of n is given as 1 by 2 pi e raised to j n minus 4 upon j into n minus 4 ranging from minus 1 to 1. So it will be 1 by pi into n minus 4 e raised to j n minus 4 minus e raised to minus j n minus 4 upon 2j. So using the sine theta formula we get sine of n minus 4 upon pi into n minus 4. Now we also know that to obtain the value of n is equal to alpha we will use L'Hopital's rule. So it will be limit n minus alpha tending to 0 sine of n minus 4 upon pi into n minus 4 will give us 1 by pi. Now we will calculate hd of n. hd of n is already defined for these two terms, that is sine n minus 4 upon pi n minus 4 and 1 by pi. Next we move on to calculation of h of n.